So for creating all the normals, I start off with the six-sided cube. I don't hard code them. I create a utility namespace that has two methods. I pass in the data for the cube here. This method creates per face normals, gets the cross product that is the triangle, and then sets each vertex point to use that face normal. So I do this for the cube and the pyramid, same thing. And then get the face normals here. For the sphere, the normal was just normalized position. The terrain, after getting the heights, and I'll go back and it has a per vertex normals method. So it's the same thing. It's a per face normal, but instead of setting them here, it sums them up and then averages them at the end. Each shared index result. So all the shapes look fine, and the terrain looks fine as well. The second one I started off by abstracting out the color light shader because all this stuff, like all these methods, are like 95% the same between the texture one and the color one, except the texture one is like a set texture method. Probably not even what they need, but so the only reason I had to do this is because the constructor it's protected here and has to take the shader path, which is different. That has to be different. So here, since it derives from the base now, it takes in its color light shader. The texture one takes in the texture shader, has a different input layout. C now looks the same. So it's texture and everything. So for the shader for this is pretty much the same, except here there's a texture and a sampler in the shader code now. It multiplies the color by the sampled color value from the texture coordinates. The third question started off by again abstracting out for the multi-lighting. How I did this was I changed some of the structures around. I also put the lighting in a header file because I use a lot more constructors to create some of the data instead of like vectors in the methods. And then I have the arrays. I have a max fixed size for now. I guess probably all the time. And this num active array, I had to pack it like this because it wouldn't let me like work with like int, like two ints that said num active spotlights or num active point lights, and this is it for the looping inside the shader to calculate how many active lights. Because now you're not going to use all 10 of these, maybe. And this bait class just takes in and some of these methods. This one takes in, you can pass in numbered set and then like array of point lights. So it's it here, and then same thing with spotlights. And you push the data here. Shader code. And the pixel shader has two loops now for the spotlights and point lights. So there's a point light here, a point light here, and there's a spotlight here. And then the textured one works the same way, except at the end multiplies it by texture color. The further work was asking about the tune shader. So I put to test it out, I put like the setting of the max values here, and if I uncomment them out in the shader, what it does now is it doesn't smoothly fade out anymore. The contrasts are much more glaring, as the book say that it would work this way. So that's the only real result I found from it, is that there's no more smooth shading the lighting. It's all just very high contrast.